Hi, everybody. This is George Mamalakis. Thank you for having me with you. I work in Meta as a production engineer, and I'm here to talk with you about how we at Meta handle disasters of our data centers. So let's take Hurricane Sandy, for example, 2012, when all this started. The hurricane was coming close to two of our largest data centers at that time in Forest City, and one leased data center that we had. At that point, we weren't sure if it was going to bring us down, and we had an issue that we realized that if either one of them got down, the whole Facebook network would be down. And that was because in FRC, in Forest City, there were all our primaries of our databases, which meant that if it fell down, nobody would be able to write something there. And if the leased data center that we had back then was going down, we had our underwater optical fiber, which connected us to Europe, which meant that we wouldn't be able to serve the two regions simultaneously. So this is when we asked the question to us, are we able to function with one data center down? And this is where the disaster recovery program at Meta started. So short layout of the presentation. We're going to start with how we approach the disaster recovery at Meta at first, then the challenges that we had to face, which are related to scale and dependencies mainly, the platform which we created to help us in these situations, the current status, and the future work. So to answer the challenging question that can we run Facebook with what of our data centers down, we need to understand a bit how request goes to our data centers. So from a 10,000 feet view, if we open our, let's say, app, the Facebook app, what happens is that eventually in one of our data centers, the request will eventually reach to one of our application servers. So when this is done, this application server will talk to multiple microservices which serve the feeds, the likes that you see, the reactions, or the ads, right? So what would happen if a disaster occurred? Like hurricane, for example, right? Or wildfire or something. Then there are different approaches that threaten our data centers, and what we ideally need to do would be to spread all the workload to all the other healthy data centers. So reroute our traffic to be served from the other healthy data centers that we have around the world. This redirection of traffic from one data center to the rest of them is what we at Meta call a drain. So this drain thing should be relatively simple, right? You reroute traffic from one data center to the rest of them and you're fine, right? Well, short answer is no, it's not that simple, because as we said, the application server talks to various microservices which have their own dependencies, which have their own provisioning strategies and have their own issues sometimes. And these are thousands, not just tens or hundreds. So this makes things quite complicated. And if you add these, let's say, services, microservices into the various data centers that we have around the world, the problem becomes even more challenging. So this is the scale of the problem that we needed to solve. Now, what the main challenges that we had here was, first of all, that not all of our data centers have the same hardware because they don't serve the same purposes. Some of them are dedicated, for example, to storage. Some of them are for application service. Some of them are for AI. So we cannot just have everything everywhere. So this is one of the challenges that we had. Moreover, the service dependencies is a big issue that we discuss about. And one other issue is that not the social graph that we have for all the information that we share for all our apps is not directly available to all the different data centers that we have. Because if we did that, this would mean that we would have unutilized, not optimally utilized our services, because we don't need it to be everywhere. and it is a huge volume of data, and we would have some issues also with local, laws, maybe for privacy. And apart from that, it's also the dependency issue that we had. So if you imagine that we have the front-end servers, we have the cache servers, and then we have the database servers. If we drain the cache servers first, that would lead to millions of requests being sent to the databases and bring them down, which wouldn't be something that we would want to do, right? Because we were trying to drain our data centers so that there is zero user impact. So we need to know these dependencies and serve them well. And at our scale, this is a picture of the dependency graph of the Facebook app, I don't know, 3 years back. So it's even more complicated now, which means that this is quite challenging to achieve. So this is how we went back to some fundamentals of reliability theory, and we need to focus on two things. Capacity provisioning, which means that we make sure that the systems are sized correctly to handle the additional load from a drained data center. And global replication ensures that the data required to serve requests is available outside a drained data center, right? So, well, as we said, the naive solution would be to over-provision, let's say, our services, but this would be huge underutilization, and at our scale, this would cost us a lot of money. So the strategy we did was to meet with the capacity planning teams and make sure that we only require the specific needed amount when the, let's say, largest data center would fall down, for the rest data center to have this capacity to serve the requests. So in terms of capacity provision, for example, what we needed to avoid was situations where there wouldn't be enough capacity in the rest of the data centers to cover the increased workload caused by a drain, right? And as a company, we decided to add an extra capacity buffer, the point that you see there, for each deployable service. And this is what we call a DR buffer. So this buffer ensures that each service has enough capacity in a healthy data center to serve the redirected traffic originating from a service that data center that is being drained. Now, this is how we started. Back in 2013, I think, this is the methodology that we used. We had a whiteboard with some steps written on it to make sure that we know how to drain one of our data centers. Well, it doesn't look much, but this helped a lot in us understanding, first of all, the dependencies among our services and have, let's say, a plan of how to drain a data center normally. And it was simple, right? But it wouldn't scale. And as we grew from 3 data centers up back then to the 5 that we had next, we moved to an Excel spreadsheet, which it made, tracking a bit easier and more, visibility was better. Still, it couldn't scale more than that. And to automate this procedure, we came to DR Platform, which is the team I'm working with, which basically automates this process to make the human error as negligible as possible and be able to track down correctly what is happening in an automated way. So this is how DR Platform looked a few months back. Each line of them is a step to be executed from a runbook, which is, let's say, a set of steps that need to be executed in order to drain something. We can see with purple that these are the steps to be executed. We see that the changes state at some point and are going to running, as you see. And then some of them, when they're executed, we see them being marked as done. And this means that this step has concluded. These steps have their own interdependencies, which are handled by our scheduler, which runs on the back, which does all this, the dependency graph and follows the order of the steps as they need to be. So what we do now with this technology, with this platform, this allows us to be able to validate whether the DR buffer that we have, let's say, calculated, and if the services that are constantly in flux and are changing, and you can see dependencies, creeping up from new apps that we're, let's say, bringing in the way, we can test whether the services are still DR ready. So using our own tooling, we do this exercise, which is called storms, which is with zero advance notice, no advance notice. We drain one of our data centers, and we expect that nothing will be, the goal is to have zero user impact. And this is almost always happening. We do them 4 to 8 times a year. And this is a way that we can make sure, in a sense, that we're still DR ready, so disaster ready. And this is a way that we try to follow. Now, in action, when the Hurricane Florence was hurtling towards the Forest City data center that we had, we took our tooling, we drained it successfully within 2 hours. Fortunately, the hurricane didn't strike our data center, but nobody had, there was no user impact at that point. We were very happy that everything worked as expected with the various tests that we had done up until that moment. And this is how we used it. Now, of course, this doesn't handle all types of, let's say, disasters that you might have. This is for large-scale disasters, for data centers. This methodology cannot handle configuration errors or, I don't know, software errors or bugs. Now, in terms of our future work, the things that we mainly are focused on now, this is the last year and we're still under development for this, is the multi-regional disaster recovery, or MRDR as we call it. As our fleet grows and grows and grows, we have calculated the probabilities of having a failure simultaneously in more than one of our regions. And this is becoming non-zero-ish as our fleet grows. So what we're now trying to handle is whether, first of all, our platform that we created 5 years back is ready to perform such tests, and mainly whether our, let's say, capacity planning is ready to hold, and our deployment is ready to handle all this. We had a situation in 2022 when one of our data centers in EU had problems with power because there were some, I don't know, strikes, something was going on at that point, and we had to drain the data center to make sure that there is no user impact. We started draining this data center in Europe, and at the same time, in the US, some configuration error caused most of our servers of one data center to go out of memory. So this made the need to, again, since people were affected by it, we need to drain this data center as well. We were lucky enough that the power in the European data center had come back by then, so we started undraining that data center, and then we started draining the data center in the US, so we didn't have to go exactly to this MRDR scenario, but this made it very clear to us that this danger is way closer than we expected it to be, and we're not 100% sure if we're ready to do it. Now, the second path that we're following now is the power storms. Power storms are tests which test whether we can, apart from, reroute all traffic from one data center to all the others, it's also the fact what happens if the power is lost. You might think that it's the same thing as it would be with, just draining the data centers. It's not the same case, because when the servers are up, they don't need to recover from some other state, from some zero state, so everything works just fine. So we started doing one such test this year. We realized that there are issues that we had never thought of. We found out some services were having dependencies while they were bootstrapping on some other services which depended on them as well. So we had circular dependencies. And even worse, we found that one of our biggest services had a self-dependency on itself, right? So this was a huge thing finding for us. And this proposed also, again, made obvious the need for us to move on with power storms and tests in the future. So with that, thank you very much for your time. I hope gave you a 10,000 feet overview of how we handle things at Meta in terms of high-scale disasters in our data centers, and I'm happy to answer your questions.
Have you got any processes around perimortem, postmortem for if something breaks this, how to, once you have recovered, factor that into the plan for the future?
Let me ask you again a question to understand what you mean. So sorry, can we have the mic back? Because I didn't understand your question correctly. So what was it exactly? Let's say that the disaster comes, right?
Yes.
Everything is heard, and then what is the plan?
Yeah, what is the plan for once you have fixed something that has gone wrong,
Yeah.
and you have recovered,
Yeah.
adding prevention into the future to prevent it from happening?
Yeah, this is a good question, first of all. What we do at Meta is something that is done also in many other tech giants. It's what we call a SEV, a site event. So whenever something breaks, we have a specific methodology of filing these things. And then every person or team which is involved in this tracks this down. It has follow-ups and makes sure that these same, let's say, mistakes don't happen again. So, and this is not just for disasters of this size. This happens in a daily basis. We have thousands of SEVs per day because we have different levels for them, right? We have from SEV 0, which is the things that you've seen last year, we were out for, 6 hours. This was a huge SEV 0 for us. We also have smaller ones that you may not notice, but still are, we are keeping track of them using this methodology and making sure that there is always a test which ensures that this doesn't happen again. An alert before that happens or whatever needs to be done. And ideally, it's done automatically. Any more questions? Yes?
Do the applications know that this is happening when you're draining a data center, or do they just see less requests coming in? Is it an active process?
I'll tell you. So for us, we don't care. They shouldn't care. What we tell them is that you should be prepared for this. As a client for us, which is the services, it's, Instagram or Facebook, whoever, they need to be prepared and do whatever is needed for them by following the, let's say, best rules, the best practices that they are taught as teams to make sure that they're, whatever happens to them, they're ready for such disasters. So they know the type of disasters that we are testing them against. They know that they will happen 4 to 8 times a year. They don't know when. They have zero notice. In the past, we gave them notice, about a couple of hours or something. And in the beginning, 8 hours notice or 12 hours because they needed a lot of time, to prepare. Then we realized that they shouldn't be prepared because, that the disaster can come at any time. So we wanted to make sure that they, without them noting anything, they're ready for such disasters by design. Any more questions? Thank you very much again. Thanks for having me.